So we're going to do a little revision here. That's where we ended up last lesson. But testing our understanding on using this. We do also have the table of values that's given to us. So if we know a probability is 50%, the Z value would be 0, which makes sense because 50% of the data is around the mean. But this always goes from the greater than value, which is why all of these Z values are positive. As we know, the normal distribution curve is symmetrical. So if I did want a value that was, let's say, 15% of the data was less than it, it would be the negative of the Z value. That's 15% greater than. Go ahead and try these and see if you can figure out how to do them. Pause your video. With this first one, it says the top 10% of people. And as we're given our X information of the mean and the standard deviation, but not where it's at and the probability, we can use our Z and say the top 10% will give us this value here. That allows us to set the equation equal to it and solve for X. We're going to do the same thing, but this time the bottom 20% means I'll look at the top 20% and due to symmetry, take the negative of it. Oops, sorry. And take the negative of it and solve for X. For this next set, it wants us to write it in terms of phi. As this is, as we remember, hopefully from last lesson, is phi is always the probability that Z is less than. So we first need to convert 115 to Z. Once you've done that, take away the mean, divide by the standard deviation. You then need to do 1 minus as phi is less than. And as you see, that's exactly 1 standard deviation away. So it'll be 1 minus phi 1. Now this next one's a little more complicated. As you see, because we want the in-betweens, it's the same thing as saying taking the part that is less than 112 and take away the part that is less than the 77.5. This does help if you have a little sketch there, and then you can see that everything that's less than 112 except for the part that's less than 77.5. Start by converting it to Z. We then can do the less than. Now this could be a negative 1.5. The Z is positive. So we know from symmetry that we can do 1 minus that. So that negative kind of came out front there for it. And then just rearranging it, they've put the negative 1 at the end because we've expanded this negative. And that's it in terms of phi. That one might be a little complicated, so you might want to try it again and make sure that you look out for problems like that. For these next two, definitely sketches help in my opinion. As we know that we're between the positive and negative of the same A value, that means they're symmetrical. And if 10% is above the mean to A, then we know 40% is above A. And that allows us to use our table and figure out the Z value. The next one, 0 we know is 50% mark, and it goes at 35% more, which means 15% is above it. So using our table again, we can get those values. Now, in the first few sections, you guys learned how to find an unknown value or how to use a probability or find the probability if you don't know it using your calculator. So you might be asking yourself, why bother with all of this? Why bother with standard normalization? And that's what brings us into our next section, which is what if we have mu and sigma missing? What we'll do in this case is, this is an example from your textbook, is we have mu and a sigma of 3, but the mu we don't know. However, we do know the probability that x is greater than 20 is 0.2. Do you suggest using a sketch first, as it's always helpful? And knowing that x is greater than some value gives us a probability of 0.2, we can figure out the z equivalent. So looking at that, 0.2, our Z equivalent will be 0.8416. We can then equate with the X value of 20, the Z value of 0.8416, and use our formula and say that 0.8416 is our 20 minus our mu divided by our sigma. In doing so, as we only have one unknown, we can now rearrange the equation to solve for mu. Go ahead and see if you can give the next one a try. So as you can see, the first thing I did is my always suggestion of doing the sketch. With this, I'm then going to go to my calculator. The reason why I'm going to my calculator this time and not the table is because this percentage is not represented in our table. So 119. I'm going to go to distributions. And then I have the probability, I need the Z value. So given the probability, we use inverse normal. Using inverse normal, the area is 0.2119 because it's the probability. And our sigma and mean for standard normal distribution is 1 and 0. And that gives us our Z value of negative 0.7998457306, and that's the Z that matches this X. Now to three significant figures, this would be 0.8, so I am going to go ahead and use 0.80. More significant is always better than less if you're not sure of where to go to. So we're going to say that the probability that X is less than 46, we know is the 0.2119, and that is equivalent to the Z value of negative 0.80, and if we use it, X minus mu, which we do know in this case is 50, divided by sigma, which we don't know. We can now go ahead and solve it, and you should end up with sigma is 5. Part B then is using this information. We now can say for part B that X is distributed normally with a mean of 50 and a standard deviation of 5. And that comes from our answer above. And they want to know the probability that X is less than 0.9. So we're going to go ahead and use our inverse again. So I'm just going to go ahead and clear this. And we're looking for 0.9 as the area. This time we're going with 5 as our sigma and our mean of 50. And that gives us a value of 56.41 to 4 significant figures. So I'm going to go ahead and say that our value is 56.41 centimeters. So this question asks us what happens if we're missing both of them. And that's where you'll be given 2 pieces of information because you have 2 unknowns, and you'll set up a simultaneous. So in this case, we're dealing with a past paper problem from January 2011. And it tells us that the weight of Y grams of soup can be put into a carton by a machine B is normally distributed with a mean of mu grams and a standard deviation of sigma grams. Given that the probability that Y is less than 160 is 99%, and the probability that y is greater than 152 is 90%, find the value of mu and sigma. And you can see that one of the hints that was given to us here was that ClassWiz does allow us to solve simultaneous equations. So see if you can set up the simultaneous equations and then solve them for this problem. You should have started by figuring out the z values that link to these, just like we did on the previous ones. Using the z values that we get by doing inverse with standard normal distribution, we can set up these two equations. And in doing so, I'm then going to rearrange them and say 160 minus mu is 2.3263 sigma. And then the same thing, except with the numbers for the second. Now, if I go to my calculator and do menu and A, it allows you to do simultaneous as number 1. And in doing the simultaneous, we have two unknowns, so I'm going to hit 2. And you can see that it says how many x plus how many y equals 0. So I'm going to let mu be my x and sigma be my y, but they need to be on the same side of the equation. So I'm going to rearrange this for both equations, so that way it's in the form the calculator needs. Now that I have that, I can go ahead and set up that 1 mu equals positive 2.3263 for the sigma, and that's equal to 160. Hit equals again, and set up the values for my next equation. So 1 mu negative 1.2816 for my sigma, and 152 as the constant. And it tells me that x, and x was my mu, is 154.84, and sigma was my y, and it tells me that that is 2.217. So that's how I can use standard normal distribution to set up two equations that then allow me to do simultaneous to solve. You can see here the mark scheme that they put together for it and where all 6 points came from. This does mean answer which rounds to, so our solutions, which were more accurate, in the case of the sigma, is alright, as long as you just aren't less accurate. Here's two more problems that again use standard normal distribution, and they are from past exams. So go ahead and give them a go, and then see if you got the answers right. Go ahead and now do exercise 3E, and if you have any questions, let me know.